Hi there, I'm Doug Allen, and I'm going to talk to you about ocean innovations, the future of blue science. And I'm going to run through a number of things. Some of it is good news, and some of it is not so good news. But these are one, two, three, four. These are half a dozen of the big factors that I see as being important. Plastic pollution is huge, isn't it? And to be honest, we don't really have a problem for collecting the plastic that exists. We've got boom ideas, we've got all kinds of stuff out there floating, but none of it is really. The biggest solution would be just not to put this stuff in the ocean in the first place. That's what we're looking to do. And especially microplastics. Microplastics are a real problem. I'm going to go back a little bit. There was an interesting Irish young boy who developed this, what's called a ferromagnetic liquid, which is, he developed this oil which actually sucks microplastics into it. And that's a small, that might just work in terms of sucking some of the microplastics out. But to be honest, it's a problem we're going to be stuck with a long time. And what we need to do is stop putting it into the ocean. But that brings me to one of the big solutions that we've got. There is a company in Scotland which produces from waste paper, produces a compostable, biodegradable packing thing. And next year, in February next year, they are bringing out a paper bottle. And this is a bottle which, with a special lining inside it, will contain liquids. Everything, the bottle, the liquid, is all biodegradable. Put it into your compost heap, and in 8 months' time, there is nothing left. Throw it into the sea, and it disappears in about 3 months. And this Cullen, which is the name of the company, Cullen's paper bottle, is something that we should all be on the lookout. It's a similar price to plastic bottles, so it's got everything going for it. And I would like to see those paper bottles being taken up by everyone. They're already talking to people like Tesco, Holland and Barrett, Amazon, and they're all interested in it. So this is what we want to do. Overfishing is a big problem, isn't it? Well, we can now, so to speak, illuminate the dark fleet. Achieving a comprehensive view of fishing activity is an important step towards effective fisheries management. And the Global Fishing Watch, they track fishing in certain parts of the world around the Koreas, Japan and Russia. And what they do is they use a combination of satellite imagery and also AIS. AIS is automatic identification system, which all ships are supposed to have. All ships are supposed to keep switched on, but actually they don't. They keep it dark. These ships want to operate without anybody knowing where they are. So the Global Fishing Watch, they use a couple of satellites, several satellites in fact, and they can look at optical imagery gathered by Earth-observing satellites. They analyse wide-field photos, which are collected by a certain kind of satellite, as well as targeted imagery from larger satellites. They also use infrared, which allows them to work at night, and the infrared imaging can also pick up brightly lit ships at night. And these ships do illuminate themselves because they're hunting for squid. So that's the good thing. We are able to look with new technology, to look at areas of illegal fishing. One thing that's not so great is that people are looking at deep sea mining. You know, there are the world is not running out of land-based metals, but we do need, there's an awful lot of rare earth metals used for clean energy technology, such as wind turbines, solar panels, etc., electric vehicle batteries. Now, the world isn't running out of land-based minerals, but mining these resources comes with a heavy environmental burden. So what the miners are looking for is going underwater and deep mining it. The trouble is that the sort of machinery they're using would come ideally out of a James Cameron movie. It really is big and rather a little bit iffy as to how they're going to do that. The idea is these things trundle across the bottom and they pick up manganese nodules. These manganese nodules are very rich in the sort of minerals that people are interested in. And there's trillions of these nodules. They're about the size of potatoes, and they lie at a water depth of between 4,000 and 6,000 metres in the a 6 sort of square kilometre region of the Pacific Ocean between Mexico and Hawaii. And it looks very smooth the way that they're going to do it, but actually, when you actually put a camera on these sort of machinery as they're trying it, you see there's a big plume of sediment comes out, and there is a real concern about this sediment plume affecting far more than just the area that they dredge across. There's a danger basically of deep sea mining doing the same as deep sea trawling, just dragging something across the bottom and losing so much of it. So there's also a danger that a lot of these very richest areas that they're interested in are places that might have hydrothermal vents, for example, in them. So although there is, comparatively they're looking at a fairly small area of the seabed that they're going to be mining across, they could be a big environmental issue down there. And it is a case of out of sight, out of mind, isn't it? But we don't want that. So I think we need to look very carefully at mining, deep sea mining, and what it might do. On the positive side, there's some of those the deep water species that could be impacted if there was mining went on close to it. On the positive side, I worked recently on a project which took very high resolution pictures from space of coral reefs and then correlated what the satellite image was seeing with a boat which tracked across a very precise GPS track. And the idea was to look down with a camera over the side of a boat, look down at the coral and see in real time whether it was degraded, whether it was bleached, what have you. And the idea is that with these high resolution satellite pictures, if we get enough ground data on what damaged coral looks like, then we can set up the algorithms and we can look at whole areas of coral reefs that we couldn't access, would be very difficult to access with ships. We can actually do it from space, and we can assess the health of areas of coral from 1 year to the next year long term, and we can see whether they're recovering or whether they're being further degraded. They're up in Orkney and up in Shetland. They are pressing ahead with some very effective giant turbines which run off in tidal waters. The big advantage with tidal is that you know exactly when the tides are going to come. It's not like the renewables with wind and solar where they're very variable. You know exactly when the tides are going to run, how big they're going to be, years and years and years into the future. So in Orkney and in Shetland, as you can see here, we've got two kinds. In Orkney, they've just put big turbines in like this, which are called Orbital. Orbital O2 has the capacity to meet the annual electricity demand of about 2,000 homes for the next 15 years. And this 680-ton turbine is anchored in Fall of Warness, where a subsea cable connects the 2 kilowatt offshore unit to the local onshore electricity supply. And the whole thing sits there, it's sunk down into the bottom, and it's been running now for a number of months, and it's really generating some good stuff. It also provides power to an onshore electrolyser to generate green hydrogen. So this thing seems like a win-win situation, and the idea is to, if it's successful, over the next couple of years of testing, they're going to expand them into other areas of strong tidal flows, like in the Pentland Firth, for example. Up in Orkney, up in Shetland, on the other hand, there's the Orbital 2 off Orkney. Up in Shetland, on the other hand, they've got an array of these tidal generators, and these things sit on the shores of Blue Mill Sound, and these turbines are located in water between 30 to 40 metres depth. They're not visible from the surface, but the neat thing about them is that they've got them running so that these things run in the water, and they bring the power up on land, and they've got free charging points for electric vehicles up in Shetland. And that's just a small use of it. Obviously, extra power goes out to the houses, what have you. But these things are still sort of at the testing stage, but they're definitely going to be a way to get power from the sea in the future, and it's very exciting. On the other hand, here's one to be aware of. COP26 just decided to reduce by 30% man-made emissions of methane. Well, to be honest, the amount of emissions from man-made gas fields, etc., is going to be tiny compared to the methane escape from the permafrost and from areas in the Arctic Ocean. Methane in the Arctic Ocean is held in the form of crystals called clathrates, and they're held in this crystal form because of the cold water and because of the depth. Well, as the Arctic Ocean heats up, then that methane, those clathrates, are starting to dissolve, and they're starting to come to the surface in the shape of these methane plumes, which scientists are detecting up in the Arctic. And then those methane plumes are getting stronger and bigger every year. And if ever we need a reason to get control of climate change and stop the ocean warming up, it's to control the escape from methane in those plumes. So, in conclusion, some things to be very excited about. You know, we can shift, we can get rid of plastic bottles by going with a paper bottle. On the other hand, things to be concerned about: should we be deep sea mining for the minerals that we need? And definitely climate change, we have to watch methane escaping from not just the permafrost, but the methane underneath the Arctic Ocean. Lots of food for discussion.